Hello everyone. For the next part of today's lecture, I'm going to go through the rock, paper, scissor example as a demo for the choice function in numpy.random module. We are going to try to answer a couple of questions about this example. Let me switch over to Jupyter Notebook. Go ahead and pause the lecture video here and download the template notebook file for today's lecture in order to follow along the lecture demo. I'm going to briefly go over the import statements here. I'm importing pandas module as PD, and then I'm importing numpy module as NP. NP is the most commonly used short name for numpy module. All of you should have numpy module installed on your laptop because you have already installed pandas. Then I'm importing the choice function from numpy.random module. I'm also importing series and data frame from pandas. I'm importing matplotlib to be able to set the font.size aspect of the plots using RC params. I've already answered the question 1 over here. As I mentioned as part of the previous lecture video, option 2 is the one that I generated. The main reason for that is we have exactly 8 heads and 8 tails. The probability of that happening is little low. Let's go through the choice function. I'm going to call the choice function with a list of items as argument, and the items are going to be rock, paper, and scissors over here. So if I run this cell, I'm going to get a different value every time I run it. I got paper first. Looks like we're getting paper a lot. That's okay. Now we have scissors, and now we have rock. Right. What we are going to do now is we are going to see how we can select multiple values out of the choice function here. We can do that by passing the size argument to the size parameter. The argument to the size parameter can be two options. The first one is just passing an integer value. So I'm going to say size equal to 5 here, which is going to enable me to select 5 items from the initial list of items over here. How are we able to select 5 items from 3 items? That's because we are doing sampling with replacement, right? We select one of the items and then we put that item back into the original list of items. So this function call is going to return what is called as numpy array type. Let me show you what is the type of the return value here. That's going to be numpy.end array. All that you need to know about the numpy array is that it works similar to a Python list. So you can capture the return value of the choice function into a variable. Just for an example, I'm going to use the variable a. Please don't use variable names like a in your actual program. I'm going to display a. Let's say that I want to access the item scissors over here. I can do that by saying a of 3. That's going to be 0, 1, 2, third index position, correct? We can very easily convert the return value of the choice function into a series, provided your argument to the size parameter here is one integer value. Since we have an integer value, I can convert the return value to a series simply by saying series of choice function call. That's going to give me a series which contains 5 values. The number of values is coming from the argument to the size parameter over here. Option number 2 for size parameter is passing a tuple of 2 values. When you pass a tuple of 2 values, the first value is going to represent the row dimension of your matrix, and the second value is going to represent the column dimension of your matrix. Let's say that we are interested in passing a tuple of 2 values as 5, 2 to the choice function. That's going to generate a 5 cross 2 matrix, and you're going to get a multi-dimensional array over here. Let me go ahead and display A. Let's say that you want to access the second item in the third array within your multi-dimensional array. You can simply do that by saying A of 2, first of all, to get to the second array, and then you're going to have to say A of 2 of 1 to get the value scissor out here. You can convert the return value of the choice function where you pass tuple as the argument to the size parameter easily into a data frame. You can just simply say data frame of the choice function call. Notice that you're getting row index values as integers and also column names as integers. That's happening because those are the default values. If you want to explicitly set them, then you can pass an argument to the index parameter in your data frame function call, and you can pass a list of column names to the columns parameter in the data frame function call to be able to set the column names. The first question that we are going to go through here is this particular example giving us a fairly random output? And I'm going to use the series version to answer this first question. What I'm going to do is I'm first going to change the number of items as 15. Let me capture the return value into a series S, and let's take a look at S over here. What I want to be able to do is to create a bar plot that represents the count of each of the unique values in the selections that we have made over here. Recall that we went through a lot of examples similar to this as part of the plotting series of lectures. We can get a count of series by simply saying series.value underscore counts. Let me capture the return value, which is going to be another series, into a variable called VC, and I'm going to display VC. The VC series is going to contain as index the unique values in the series S, and the corresponding values are going to be the corresponding counts, and your value count series will always be sorted based on the counts over here. It will be sorted in a descending order. So if I say vc.plot.bar, that's going to create the bar plot that I mentioned just a couple of minutes ago. That's going to create a bar plot for these three bars, which are represented using the VC series over here. So if I keep running this cell over and over again, notice that the bars are the only things which are changing. The items of paper, actually, my bad. Let me fix that. Please ignore the previous statement. So when I run this cell over and over again, what you're going to see is, you're going to see as the first bar the topmost count. So the item itself will change, but the first bar will always be the tallest bar. My apologies for speaking earlier about that. So we are going to have different items every time we run the cell, but the bars themselves will always be in descending order. What can we do to ensure that we are able to sort the bars by a specific ordering of the items instead of the ordering of the values, which are the counts over here? We can use the sort index function call by simply saying vc.sort underscore index. Let me get rid of the last two lines over here. That is going to sort the value count series based on the index rather than based on the value, which is the default. So we are always going to get paper, rock, scissors over here. So if I run the cell multiple times, notice that you're always getting paper, rock, scissors, no matter whatever the corresponding count is. Recall that sort underscore index function call returns a brand new series. So I'll have to capture that back into VC variable to be able to create the plot for it. So now if I run this cell multiple times, you're going to stick with paper, rock, scissors as the order, but the bars themselves are going to change. What I want to show next is, other than just using the index sorted order, how can we explicitly mention an order to our bar plot list of items over here? What if we wanted to generate the plot as rock, paper, scissors, because that's the most common way to mention all of the values over here? We can very easily do that by passing a list of items to VC here. Recall that you can pass a list of column names by simply saying rock, paper, scissors inside this list. So I want to be able to pass this list, which is given by the inner square brackets, as the ordering for my series. So I'm going to say VC of that list. So that's why you're getting two different square brackets here. And then I can capture the return value back into VC, and I can simply say VC dot plot dot bar, and that's going to generate the ordering as rock, paper, scissors over here. Let me capture the first line back here. Give me just a second. Sorry. I'm going to show you that multiple runs of this cell will generate the same rock, paper, scissor ordering of the bars over here. So I copied and pasted the choice function call and also the value counts function call for that series. So notice that we are getting different bars, but the ordering itself is saying rock, paper, scissors over here. So the first question which I want to address for this example is this selection really fair? How can we tell whether we are getting a random number of choices for each of those values here? We can answer that question by going through a really large sample, right? So let's say that we try 3 million values. So I have a 3000, and then I'll have to say um, couple three more zeros here. Since we have a computer, we can run a large number of selections to the choice function call over here. Notice that if you try out 3 million selections, then you're almost getting same size bar for all three choices here, which are rock, paper, and scissors over here. What if we wanted to control the probability of occurrence of a certain item in rock, paper, scissors over here? We can do that by passing an argument to the p argument in the choice function call. We need to be careful here. The choice function call is the inner one. So I'll have to pass p as the list of probabilities, and the probability lists themselves are going to be values out of 1. Let's say that I want rock 0.1 with a 0.1 probability, and paper with 0.2 probability, and scissors with 0.7 probability. I can try to run this and notice that we are getting almost 10% for rock, 20% for paper, and 70% for scissors. So if you repeat this cell execution, you should see a similar output for multiple times because we have a really large sample over here. So if your sample is small, then you might see different bars, but since we have 3 million samples, you're going to consistently see the percentage values for each of those items to be closer to the probability values that we defined as part of the choice function call over here. Right, I will go through one final thing about the choice function, and we'll wrap up this lecture video here. The next couple of slides represent the same things that we went through as part of the demo. You can go through that on your own time. What I'm going to show you is that the choice function in numpy.random module can also take just an integer instead of a list of items here. Let's say that you want to randomly select an integer and you want to make the selection from 0 up until a certain integer value. You can very easily do that by passing choice of 3. Let's say that we want to select items from a list of integers of 0, 1, 2. There is a shortcut for you to do that. Instead of saying choice of list of 0, 1, 2, you can simply say choice of 3, which is going to get you the same output over here. Let me quickly demonstrate that in the notebook file. So I can say choice of 6, and I can say, first of all, let me display choice of 6 output. Notice that every time I run it, we are getting a different value from 0 to 5. The argument that we pass here is exclusive, just like a range function call. The choice function call, when you pass an integer as an argument, works very similar to the range function call. So you can get multiple items by saying size equal to 5, and what that's going to do is we're going to get a numpy array of 5 choices, and of course we can convert that to a series by saying series of that. Alright, I'll wrap up this video here. In the next lecture video, we are going to talk about randomness and bugs.